Chicago's very own WGN News.
Plastic pollution, it is a major global issue, and scientists around the world and our own backyard are looking at ways to solve this problem. Dr. Ludmilla Aristilde is an environmental engineering professor at Northwestern University, leading a team that is breaking new ground into this field here. Doctor, thank you so much for being with us here. We know that this has been a major threat, but can you first set the tone by letting us know how bad this problem has gotten worldwide?
Yes, so now people, other researchers, not in my group, but around the world in the ocean, in rivers that are running through our cities, as well as in our wastewater treatment plants, we're finding plastic materials of different sizes from very tiny pieces that are problematic potentially for aquatic health and for ecosystem health, as well as bigger pieces of materials of plastics that are found everywhere, because plastic materials are everywhere in our society right now.
Yeah, we're talking hundreds of thousands of tons, right?
Yes.
So your work has to do with harnessing the power of bacteria as best, and I guess as briefly as you can. Tell us how that works and how you discovered this.
Yes, so microbes in the environment have the ability to degrade complex materials because they have to do that anyway for surviving in their own environments. For example, if you were to walk in a forest and you see a branch of a tree in the soil, if you go back in a year, it's partially degraded, and that's thanks to microbes. So they're able to do complex degradation already. But what was found was that in urban rivers and in wastewater treatment plants, there are certain families of bacteria that can degrade plastics or that can survive on plastic materials. But people didn't know how they were doing it and by what mechanisms. And if we can figure that out, that we can actually leverage this ability for engineering purposes. And that's what we figured out in our study.
And plastic, as I understand it, can take anywhere from 20 to 500 years to break down. How much faster do these microbes actually break down the plastic?
Yes, that's an excellent question. So I like to remind people that bacteria, they have a very small body. So they only need a very tiny piece of the plastic to actually build their body, like their biomass. But for us humans, obviously, we want them to do this much faster. So what's good about what we figured out is that we can take this enzyme that we figured out, which is a protein that can degrade this plastic, and the mechanism that we find out, we can actually engineer it and optimize it to actually harness this power for biodegradation for our purposes. But the way that the bacteria are doing it naturally is slow because they're doing it for themselves, not for us.
So it's a naturally occurring process, but through human technology, you're speeding it up. So how that works in the water treatment aspect, and I guess that helps fix, not only the rivers, but also oceans downstream.
Yes, so in our study, we figured out we identified the enzymes and we figured out how the enzymes are doing it. So we were not actually developing the technology, but in order to develop the technology, we need to know the machinery that we need to develop. So we now have found out how they do it. Now there is a way forward for the next set of researchers and engineers to take advantage of what we have figured out to now engineer technologies that can leverage this mechanism to speed up the plastic degradation process in a way that is sustainable and really beneficial for society.
So you're working on this at Northwestern. I imagine there are other scientists all around the world that are focused on this. How excited are you about the possibility of really cutting down on global pollution?
No, it's very exciting. What's been so exciting about this particular work that it's been picked up in the Netherlands, in Germany, in France. So people around the world are very interested in this work because there are thousands of studies that have reported that natural microbes can degrade plastics. But what is distinct in our study is that we have figured out the mechanism for this family of bacteria. So if we already know that microbes can do it, now that we have, at least for this particular set of family of bacteria, we figured out how. Now we say, okay, now we have a way forward to really take this biological process that can then be employed all around the world to deal with this plastic pollution problem.
Doing very important work right here at home. Dr. Ludmilla Aristilde, thank you so much. We appreciate it.
Thank you so much.